Hey everyone, today we are continuing in our transformation chapter, and today we are going to specifically talk about translations. A translation is a transformation where all of the points in the original pre-image are going to slide the same distance and direction into a new image. So if we look here at triangle ABC, okay, every point is going to slide this far to get the new triangle ABC. So we've called these in the past just slides, and all you're doing is just shifting it around the page. It's not changing its direction, it's not changing its size. It actually moves along what is called a vector. Okay, a vector is going to show you the distance that it's going to move. It's going to have a horizontal and a vertical distance as well as a direction. So if I look here, okay, these are vectors. So a vector has an initial point, which in this case is E, and a terminal point, which in this case is F. Now, vectors are going to look very similar to rays, but there is a stopping point here, all right? So the important thing is to realize is it's going to look like a ray, but it's not a ray. It does start and stop. So the way that we notate that we have a vector is we use component form. So what's important here is that when we look at component form right here, we are noticing that those are not parentheses. They are what we call angle brackets. So please make sure if I'm asking you for the component form of a vector that you are making sure that your vector notation looks like an angle bracket. If you do kind of a wiggly one that's kind of not really a parenthesis and not really a nice sharp angle, we're not going to know what you're talking about and you will get the problem wrong. So please make sure when you're making those vector notations, those nice sharp angle brackets. All right, where when we're looking at this, our A value is how far left and right we go, and our B value is how far up and down we go. We always start at the initial point and then go towards the terminal point. So let's take a look. Okay, if I look at this image over here, we're looking at vector PQ. I start at P and I end at Q. I know I end at Q because that's where the arrow point is. So to go from P to Q, I'm going to go to the right 5 boxes or 5 units, and then I'm going to go up 3 units. So just like when we write a point, we write X direction first, then Y. It is the same thing for a vector. We're going to go to the right 5 units and up 3 units. Okay, if I were to do this the other way and do vector QP, it would be -5, -3 for vector QP. Okay, but again, this one is PQ. The other way that we look at naming vectors is we name them just like when we did with rays. We name them with that initial point first and the terminal point second. Or sometimes vectors will also have a naming letter. And the way that we notate the vector here is notice that it's similar to a ray, except it is only a half an arrow on the top. So this one would be over to the right, would be vector PQ because we start at P and end at Q. We don't have the full arrow because the full arrow is the ray. The half arrow tells us that we have a vector. Okay? And there are 2 ways to notate translations with a vector. We can use translation notation, which is right here. Okay, we're going to put our vector in the subscript. So like if I was using 5-3, I would do T for translation and then 5-3. And then I would do triangle ABC or whatever that I was translating. So T for translation, the vector goes in the subscript for T, and then in the parentheses is what you're translating, whether it's a point or a figure. And then we have one more type of notation, and that is actually on the back here, which is coordinate notation. So I'm going to say if my vector is translating A, B, we're going to do x plus a, y plus b. Because that's what's going to happen with every single point, and we'll talk about that again in a second. So if you have any questions about any of those pieces, okay, go ahead and write them down now, and we'll talk about them some more as we kind of go through here. So if I look at example 1, I want to start by naming the vector. Okay, again, if I'm naming a vector, I'm using the letters of the name. So when we are looking at naming the vector, we need to first identify the initial point and the terminal point. The initial point here is M. M is where this vector starts and it ends at N. Okay, so when we name the vector, we're going to do MN with the segment bar above it with the half arrow. All right, so that is how we name this vector. Okay, then again, to write the vector in component form, we're going to identify how far left and right do we go, how far up and down do we go. So if I look here, if I'm starting at M and I'm going to N, this distance is a distance of 4, and I am going right, so it is a positive 4. So the horizontal change is 4. Then the vertical change from here to get to N, I'm going down 2, so that is a negative distance. So the vertical change is negative 2. So the component form of this vector, again, you are using our angle brackets, it is 4, negative 2. Okay? Again, if you guys have questions on that, make sure you pause the video at any time and write down any questions that you have. All right? So what we want to look at is whether or not each of these looks like it could be a translation. So if I look at A you should notice is actually a reflection because it is flipped over from blue to red. And if we actually were to draw kind of a line down the center, that would be our line of a reflection. But if we look at B, every point looks like it has slid over pretty much the same amount and same distance. So we're going to say yes, this looks like a slide. And again, we can, just like we did in the 3-1 video, where when we talked about reflection, we could use the word flip. Here, when we talk about a translation, we can use the word slide, but anytime you're describing a transformation, we want to use the correct terminology. Okay? Example 3. So example 3, if you notice here, we are given a vector v. All right? And I want to translate the vector along this triangle, or along this vector. So what we're going to do is, you'll notice I kind of already have a little copy of it here. You are going to sketch this. I know yours are not going to be perfect, and that is more than okay. So what we're going to do is, the way that this works is we are going to select this, and I'm going to put it at the end of the triangle. And right there, I'm going to draw a point. All right. Then we're going to take it to the next vertice of our triangle. And from there, I'm going to draw a point. Now again, you guys are doing the best you can to draw a vector that goes about the same direction. You may not have it perfect, and that is more than fine right now. I am not looking for perfection. And then we put it down here. And we're going to draw, that one's a little low, so we'll draw the point a little up. All right, and then we draw our triangle. All right, so again, it's not perfect. It's not by any means exactly correct, but it's the general idea. So what happens is here, every point on this triangle is slid over to its matching point in the next triangle. We've got this point here gets slid over to this point here. This point here gets slid over to this point here. So everything matches, going in just about the same direction and length. And if we were doing this exactly, it would be exactly the same amount. All right? So let's look at example 4. With example 4, we want to do our translation of this triangle here. And we're going to translate it along, oops, that did not erase, along the vector 3, 2. So we're looking to translate along this vector right here. So what that means is that, or excuse me, it's negative 3, 2. So what that means is if I look at coordinate notation, all right, every x value, I'm going to subtract 3 from every x value. So that's where we write this part here. It's going to shift up 2, so every y value gets added 2. So if I look at my first point, 0, 3, all right, I'm going to subtract 3 from the x. So my new x becomes negative 3, right? 0 minus 3 is negative 3. Then to the y, I'm going to add 2. So 3 plus 2 is 5. So this is my new point. So if I look here, this becomes negative 3, 5. So this point here is going to match up with this point here. All right. If we look at the next one, we've got negative 1, 1. So for the x value, we're going to subtract 3. So 1 minus 3 is negative 2. Negative 1 plus 2 is 1. So we're going to go from, here we're going to go to negative 2 and 1. Nope, that means this guy here is actually at the wrong spot. That's negative 2, 5, not negative 3, 5. There we go. And we're fixed. Okay, so this point here is going to match up with this point here. All right, and then we're going to look at our last one. It's not very different. Okay, our last point is negative 1, which is this point here. And we're going to shift it left 3. So negative 1 minus 3 is negative 4. And then we're going to take from negative 1, we're going to shift it up 2. So that's going to be negative 4, 1. So that's going to put us right here. And then this is our new triangle. A little wavy line there. And once we have done a transformation, I tend to like to shade in my final figure, so that way I know which one I'm looking at, especially when we start looking at multiple transformations, and we'll do that in a couple of sections. But when we start looking at multiple transformations, it's nice to shade your final figure, so we're only looking at the final ending result. Okay, let's look at one more. So we want to graph so remember, t means translation, and we're going to go along the vector 7, negative 4. So we're going to look here. We're going to start with, we have triangle EFG, so let's just start with point E. So point E is at negative 1, 2, 3, 4, 5, up 4, so it's negative 5, 4. All right, and then my vector again is 7, negative 4. So this is actually, if we look at this and kind of write this in coordinate notation, it's going to be x plus 7, y minus 4. So we can apply that to each of these. So this is going to map onto negative 5 plus 7 is 2. And then 4 minus 4 is 0. So this will be E prime. Let's actually write that in front. Okay, so we're going to look at 2, 0 here, and this is going to be E prime. All right, let's look at F. All right, F is at the point negative 1, and then it goes up 1, 2, 3, 4, 5, so negative 1, 5. And we're going to go to F prime. And again, we're going to add 7 to our x's, so negative 1 plus 7 is 6. And we're going to subtract 4 from our y, so 5 minus 4 is 1. So F prime is at 1, 2, 3, 4, 5, 6, 1. Okay, so that is our F prime. And then we're going to map G, which is at the point negative 2, negative 1, onto G prime. So again, Negative 2 plus 7, our x value is 5. And negative 1 minus 4 is negative 5. So g prime is going to go to 5 and then down 1, 2, 3, 4, 5. So here's our g prime. And then we can connect our triangle. And if you'd like to shade, shade in your final figure. All right, if you have questions, make sure you've written them down and you ask your teacher tomorrow in class. I hope you guys have a wonderful day, and we'll see you later.